Welcome everyone to Wednesday Night at the Lab. I'm Tom Zinnan. I work here at the UW-Madison Biotechnology Center. I also work for the Division of Extension here at UW-Madison, formerly the Cooperative Extension folks. And on behalf of those folks and our other co-organizers, Wisconsin Public Television, Wisconsin Alumni Association, and the UW-Madison Science Alliance, thanks again for coming to Wednesday Night at the Lab. We do this every Wednesday night, 50 times a year. Tonight, it's my pleasure to welcome back to Wednesday Night Lab Kevin Masarik. He's at UW-Stevens Point in the Center for Watershed Science and Education in the College of Natural Resources at Point. And he's also a colleague of mine in Extension here with the Division of Extension at UW-Madison. He was born in Milwaukee and went to Thomas More High School there. And then he went to UW-Stevens Point for his undergraduate degree and studied water resources. Then he came to UW-Madison to get his master's in soil science. Tonight he's going to be talking about something very appropriate since this is the year of clean drinking water. Private wells in Wisconsin. There's very few things, having lived on a farmstead, I should say, for a few years. It's good to know what's coming up out of the ground and out of your faucet. And I'm looking forward to hearing what Kevin has to say tonight as he talks with us about private wells in Wisconsin. Please join me in welcoming Kevin Masarik back to Wednesday Night Lab.
I appreciate the opportunity to be here tonight. A lot of the presentation today will focus on my experiences traveling the state, talking to well owners about water quality. Extension has this great program where we help communities organize group testing opportunities for those on private wells. They submit samples to us. We run those samples. I travel back to that community, and I give a presentation very similar to tonight, helping them understand what their test results mean and helping them understand a little bit about water quality where they live. So I've never got the opportunity to do this at kind of a statewide level or provide a statewide perspective on this issue. So this is a great opportunity for me to do that, especially given that it's the year of clean drinking water. If I highlight what I'm going to cover briefly, the things I want to cover is helping people understand if you have a well, or maybe you don't have a well but you rely on a municipal well, where that well water comes from. There's a lot of misunderstandings about groundwater and where people's water comes from. I hope to clarify some of those things today. I'll highlight the role of well construction and helping understand where people's water comes from. We'll highlight some common water quality problems, some of which might be important from a health standpoint. A lot of the complaints that I hear from people might actually not be a health concern, but might be related to the taste, the color, or the odor of the water, so we'll talk about some of those issues. Where these problems occur and why they occur is something else we'll also try to touch upon. And then scattered throughout the presentation, if there are issues, one of the other things we'd like to do is help people understand if there is a problem, that oftentimes there are very simple solutions. So what are those solutions that people have at their disposal to improve their water quality? So just getting back to the basics here, where does well water come from? Well water is simply groundwater. When it rains or the snow melts, some of that water is going to soak down into the ground, eventually reaching a point where all the empty spaces in the rock or all the cracks in the rock or the spaces in between the soil are filled with water. The top of our groundwater is basically that water table. Everything below the water table means that all the empty spaces in the soil or rock are filled with water. That groundwater is always moving slowly, oftentimes through the empty spaces in the soil or rock, to a nearby lake, river, stream, or wetland. We use wells as that access point to that groundwater resource. Those wells provide an opportunity for us to bring that water, bring that groundwater up out of the ground into our homes. Wells also provide a convenient opportunity for us to understand and measure that water quality. So really it's these wells that are the window into our water, and people's private wells, because there are so many in Wisconsin, really help us paint the picture of groundwater quality throughout the state. And you'll hear groundwater scientists talk a lot about aquifers, or we talk a lot about geology. And geology is absolutely critical for understanding things like how quickly groundwater moves or how quickly groundwater becomes contaminated. So the different aquifers, we see a nice picture from the Wisconsin Geological Natural History Survey showing that Wisconsin's geology is like a layered cake. The lowermost layer that we'd find, if we dug a hole deep enough anywhere in the state of Wisconsin, we'd eventually hit a bedrock unit, which we call crystalline bedrock. Think of your granite countertop at home. If you spill water on that granite countertop, it's not really going to go anywhere. It's not sinking into that material. So we know granite doesn't hold or store a lot of water. That's not a very prolific aquifer in Wisconsin. Wisconsin's groundwater sits in those geologic layers that occur on top of that crystalline bedrock. So it might be in southern Wisconsin here. It might be alternating layers of sandstones and dolomites. In eastern Wisconsin, it might be coming from what we call the Silurian dolomite aquifer. In most of Wisconsin, with the exception of the southwest region, that groundwater could sit in sand and gravels that were deposited when the glaciers receded. So where you are in the state is really going to determine what aquifers are at your disposal for accessing groundwater or having water for your private well. And if we look at those diagrams of the different rock types, what I'd mention is that water moving through sand or small spaces in between sand grains is going to move much more slowly than water moving through large cracks or fissures in various rocks. If the water can move through those materials easily, that means contaminants also are typically going to move through those materials rather rapidly as well, because those cracks or those fissures don't offer a lot of ability for that water to be filtered as it moves through that material. So the geology is really critical for helping us understand things like groundwater susceptibility. The different rock materials are also going to impart different chemical characteristics to that water, which we'll talk about or highlight as well. And when we talk about wells, typical groundwater access by private wells is on the order of probably years or maybe decades old. Most private wells are not accessing water that recharged when the glaciers melted. Groundwater, the well water that we access, is probably a lot younger than people realize. The closer you are to the top of that aquifer or near the water table, typically the younger that water is going to be. As you drill deeper, you're typically going to be accessing water that's older that might be originating from further away from that well location. And I like this diagram because it highlights that anything we do on the land surface does have the potential to impact that water quality below. So I want to highlight the difference between public and private water supplies. So Tom highlighted I grew up in Milwaukee. I grew up on a municipal water supply. Those water supplies, I pay a water utility bill that goes to pay a staff that is in charge of managing that water system. Those water utilities are required to regularly test that water. And if there's anything wrong with that water supply, if it exceeds some sort of drinking water standard, they're required to bring that water up to drinking water standards to make sure that it's safe to drink for those people that water is distributed to. That amounts to about 4.1 million people in Wisconsin. The other 1.7 million people rely on private wells. Those are rural wells that people out in the country use to bring water into their homes. There's about 800,000. That's the estimate of how many wells exist in the state of Wisconsin. Things to point out about these wells is they're not required to be regularly tested. There are some testing requirements at the time the well is drilled. They are required to be tested for bacteria. And as of 2014, they're also required to be tested for nitrate. Anytime there's well or pump work done or a well inspection, those wells are required to be tested for bacteria, and as of 2014, nitrate and arsenic. So those are the only times where private wells are required to be tested. And those are the only parameters that they're required to be tested for. There's a whole host of other problems that we might experience in our wells that unless you're taking it upon yourself to do those tests, we might not have a great understanding of. And if people do find something wrong with their well water, I think a lot of times the people I talk to are surprised that they're not required to take any sort of corrective action. That's one of the reasons why I hear people say they don't want to test their water, because if they find something wrong, they're scared that they're going to have to do something to fix it. And if we find something wrong with well water through these testing programs, our information is purely educational. We want to give people the tools to take those corrective measures that will help give them safe water. But they're not required to do that. So the message I often give people is that if you have a private well, you really are your own water utility manager. It's up to you to decide how often you're going to test, and if there is anything wrong, what those next steps might be. And when we look at a private well, typically all we might realize about our private wells, we might think about is that top 12 to 14 inches that sticks out of the ground. That's what most people probably think of when they think of their well. It's important to realize, though, that there's a lot happening below that ground surface that we can't see. We might like to, but it would be very difficult to understand things like, what is that rock or what is that material that well is drilled into. Without some sort of camera or visual inspection of that area below our feet, a lot of times we're using our best guess. And those best guesses a lot of times are based on reports that are filed when that well is constructed by the well driller themselves. Every well that's drilled in the state of Wisconsin is required to have a well construction report filled out at the time of drilling. As of 1988, all new wells also have a Wisconsin unique well number. That's a unique code that is specific to an individual well, and that creates great opportunities for us to do kind of data mining exercises that help us learn and understand Wisconsin's groundwater. So for the people in this room, if you're curious about things like, how deep is my well? How deep did they have to drill before they hit the water table? That metal pipe that sticks out of the ground, how far does it extend below our feet? Those are all really critical pieces of information to know that will help us better understand that private water supply. So if you're on a private well, that information is often readily accessible. And I've created or put the link on here with some information about where people can go if they're looking to obtain some information about their private well at home. So just know that there's a lot happening below the ground. Again, there's the casing, there's submersible pumps, there might be well screens, and then there's connections that connect up to that well to bring the water into our homes and into our pressure tanks. So transitioning into kind of the quality or the private well water quality concerns, most people in this room are familiar with the term universal solvent. Water is a polar molecule, which means it's very good at dissolving things. So as much as we all want pure drinking water or pure water, we have to realize that in the natural environment, we never find pure H2O. That groundwater is always going to have impurities depending on the types of rocks or minerals that groundwater is moving through. It depends on the types of land use where that water infiltrates and soaks down into the ground. It might even depend on the types of plumbing or packaging that water is stored or transported in. So Flint, Michigan really highlighted how plumbing, how the water system itself can impact various water supplies. Where the source of that lead was not the groundwater, it wasn't the lake or river where that water was coming from. The source of that lead was the plumbing system. When they changed water supplies, a water supply that was more corrosive or aggressive, it started to peel away or expose a lot of that lead that ended up in people's homes. If there are impurities that eventually reach a point where they're a concern for health, a lot of times we want to do something about it. And I think it's important to point out that if we do find contaminants in our water, there are a lot of variety of ways, treatment being one of them, that we can make that water a little bit safer to drink. So when we talk about health concerns associated with water, I do think it's important to point out that there's two different categories of health concerns associated with water. Some of these are acute effects, and acute effects are those that are seen within a short time of exposure to a particular contaminant or substance. So examples here would be pathogenic organisms, things like E. coli, which are associated with foodborne illnesses. We can also see those types of organisms in well water. And those are examples where shortly after being exposed to those organisms, people are going to develop some sort of health complication, usually some sort of gastrointestinal illness, some of which can be quite serious, especially for immunocompromised individuals. There's this other category of health effects, which we'd call chronic health effects, which result from exposure to these substances over a long or extended period of time. So things like arsenic or pesticides that we might find in well water, these are things we know that increase the risk of developing things like cancer. If these things are in somebody's water, drinking the water once or twice isn't likely to develop or result in those sort of health consequences. But if we find those things in water, especially if they're above certain levels, and people are using this water supply for years or decades while they're in the home, then those people are at an increased risk for health complications later in life. Is it a guarantee that people are going to suffer from those health consequences? Certainly not. But it does mean or is associated with an increased risk. So if we put that into perspective, I've listed a variety of different environmental kind of factors related to various chronic health concerns. I'd point out that there's a whole host of risk factors for various types of cancers. Drinking water, environmental factors being one, but there's other things like the use of tobacco products, our diet, that also have large impacts on whether or not somebody's likely to suffer from these illnesses. But if we put these things into context, we look at something like indoor radon combined with smoking. If there's 1,000 people that fit that category or that population, we would expect 32 out of 1,000 people to develop lung cancer from those environmental factors and conditions. If we look at water specifically, arsenic is a contaminant with a health standard associated with it. It used to be 0.050 milligrams per liter or 50 parts per billion. 1,000 people, if they were using a water supply with that level for years or decades, we would anticipate that 13 of those 1,000 would likely develop cancer from that water. So it's not a guarantee, but it does come with an increased risk. And we can take simple steps a lot of times to reduce those risks. If 13 out of 1,000 is not acceptable, there are simple things that people can do to reduce those risks even further. When we talk about different categories of well water constituents, there's a variety. There's literally hundreds of different tests that people could do on their water supply. I try to limit the amount of tests that people do to those that we know are going to be important, either from a health standpoint. So there's a category that says important to health. Those tests that are important because it contributes to taste, color, or odor problems that people often complain about regarding their water. And then there's other tests that we might do because they're indicators of overall water quality. They might help us understand things like how corrosive or aggressive is that water going to be. There's other useful information that we can learn that might not be directly related to health or aesthetic issues associated with well water. So in transitioning to some of the common issues or problems that people have, I'm going to start with coliform bacteria. This is probably the most important test for people on private wells to do on a routine or regular basis. The well code which the DNR administers is based on this idea that a properly constructed well should be able to provide bacteria-free water continuously without treatment. That is the one thing that DNR regulates is well construction. So they're trying to get people the best possible chance at getting a bacteriologically free or a sanitary water supply. Coliform bacteria is an indicator test. It's an indicator of the sanitary condition of that well. Coliform bacteria on their own generally don't cause illness, but the concern is that if coliform bacteria are getting into that well, it indicates a potential pathway for other harmful organisms to enter that water supply also. Sources of coliform bacteria are soils. They can live in soils or on vegetation, but we can also expect to find them in human or animal waste. So that's why we feel it's a good indicator of the sanitary integrity of that water system. If coliform bacteria is detected, if you submit a sample to a lab for bacteria, they're going to first check for coliform bacteria. If it's positive for coliform bacteria, they will then check that sample to see if it's also positive for E. coli. So E. coli, if a well ever comes back positive for E. coli, that's confirmation the source of that bacteria is some sort of human or animal waste source. And obviously that's a much more serious situation, because if human or animal waste is getting into that well, there's a whole host of other pathogens besides E. coli that we might be concerned about. Things like Salmonella, Campylobacter, Cryptosporidia or Giardia would mean if E. coli was present, it would mean that those other pathogens are much more likely to be found in that water supply. And those are things, coliform bacteria, again, on its own doesn't necessarily mean that people are going to get sick from that water. But having evidence of these other pathogens would give us some indication that that water supply is probably unsuitable as a drinking water source. We would be concerned about people being able to fend off those bacteria if this was their primary water supply. So as a rule of thumb, if a well ever comes back positive for E. coli, we generally strongly encourage those people to stop using the water for drinking and cooking until the problem can be corrected and a safe bacteria test is obtained. So the question I often get when somebody gets a positive bacteria sample is, where is that bacteria coming from? And these are pictures that I've collected over the years from some colleagues. This is the only interactive part of the presentation here. These are all bacteriologically positive wells with the exception of one. Does anybody want to guess which the good well is? I see, and I've heard some people pointing to the left, and this is not a trick question. There's obvious defects with a lot of those pictures. In the case of the one on the far right, the casing is cracked. Anytime it rains, water is falling directly into that well. There's insects that might be able to crawl into that well. That bottom picture actually shows, it's a little bit difficult to see, but if you look, there's actually earwigs crawling around the inside of that casing. If they drop into that well, those insects can carry and harbor bacteria in their intestinal tract that would cause or result in positive bacteria samples. There's a picture in the middle where the dog is kind of chained within a close proximity to that well. If it's hanging out there all day, it's probably doing other things there that we shudder to think about if that's where we're getting our drinking water from. The types of connections we have. There's a yard hydrant in that one picture that's affixed to the top of that well. We also see that there's a hose affixed to it. If that hose doesn't have proper backflow prevention, anytime you shut that yard hydrant off, all the water in that hose potentially will be siphoned back into that well. And we know hoses are kind of breeding grounds for bacteria. We need to make sure that we have proper backflow prevention to ensure that we're not contaminating our drinking water source. There's that other picture which is showing kind of large or tall grass. And there's some white specks on that grass. That's an area next to the well. This is a person that had a positive E. coli sample, but also had a bird feeder directly above their wellhead. So these are not pictures that I use to make fun of people. They're pictures that I use to highlight that we don't always think about where our water comes from. And there are very simple things that every well owner can do to make sure that they get the best possible opportunity at getting a sanitary water supply. So as unsightly as that metal pipe looks sticking out of the ground, we generally encourage people to leave that area free and clear. Anything that conceals that well is also going to provide concealment for things like small animals or insects. Keeping that free and clear also means that if a well driller or pump installer has to come and service that well, that they're not having to move a lot of material, they're not having to to disrupt flowers or shrubs that may have been planted to conceal that well. The grass around that well is probably a little bit green for my liking. I'd probably, more fertilizer applied on that lawn than I would recommend. But keeping that area pretty well manicured is probably the best thing that you could do to ensure that you're giving it the best chance at getting sanitary water. Other things to look for on your property, there's a picture of an old dug well. That old dug well, the diagram below it kind of shows if we keep those holes open, those holes represent kind of direct conduits into the aquifer. So if it floods or if it rains, that water has a direct conduit down into the aquifer where your new well might be pulling its water from. So if we don't properly fill and seal those old holes, we might be continuing to contaminate the aquifer that you or your neighbor might be getting their water from. And then I have a picture on the right showing a livestock water. That's another opportunity without proper backflow prevention, it's another opportunity for those systems to contaminate wells. So those are things that are related to well construction. Other reasons why wells might be susceptible to bacterial contamination might be the soils or the geology. And I really like this diagram because it shows in areas with very thin soils, those areas might also be more prone to having things like sinkholes. That water, that surface water, is getting into the aquifer rather quickly without adequate filtration. So in this diagram, we see that empty space, or we see the well. Basically, we have the well depth, and then we have the casing. So those black lines represent the depth of the casing, which in this diagram just extend to the top of that aquifer, which means that whole bottom section of the well is open to the aquifer. And the picture highlights really nicely that water from that sinkhole basically has a direct pathway into that well. If we extend that casing deeper into the aquifer, that means that we've sealed off that upper part of the aquifer, and now that water is being pulled from much deeper. It doesn't mean that water can't be contaminated, but we've sealed off some of those direct pathways, which means that what happens at the surface, it's going to be much more difficult for that water from that surface to get down deep into the aquifer where that well is now pulling its water from. So this diagram, I think, is important to highlight that while well depth is important, a lot of people talk about how deep their well is. That's only one component. Well casing is equally as important for determining where within an aquifer somebody is getting their private well water from. If we look at bacteria occurrence in Wisconsin wells, what we see, if we tested all roughly 800,000 private wells in the state of Wisconsin, we'd estimate that at any given time about 15 to 20% would come back positive. Some of that's due to well construction, some of it might be due to geology. Less than 2% of those samples are coming back positive for E. coli. So having coliform bacteria doesn't necessarily indicate human or animal waste. However, this would say or show that right around 2% likely do show some evidence that human or animal waste are impacting people's wells. What we might also notice about the map is that the darker areas are higher likelihoods of having bacteria. The lighter areas are lower risk. Areas where we have very sandy soils like central Wisconsin typically have a lower risk of bacteria in their wells. Sand is typically a great filter, which I think means that there's maybe less potential for bacteria to get down into the aquifer where people in the central part of the state are pulling their water from. Anywhere where the positives or the percent exceedance is greater than about 20%, to me that speaks to some sort of geologic concern, which makes those areas more prone to having bacteria in their wells. And if we look at one of those main geologic considerations, it would be areas where we have fractured bedrock, shallow soils overlying that carbonate, cracked, fractured bedrock, are areas that we would suspect have a greater potential for this geologic susceptibility or this consideration for bacteria to get into the aquifer without adequate filtration. So if people have positive coliforms, what's the procedure? First, we'd recommend people retest. And if 2 tests in a row are positive, then the next step is to identify where that positive sample might have resulted from, correct any sort of sanitary defect, disinfect the well, and then retest to ensure that that water supply is bacteria-free. For those people that have reoccurring bacteria problems, the best long-term solution might be looking at, can that well be constructed in a better way that would give it a greater likelihood of providing sanitary water? It would be great if wells lasted forever, but the older the well is, chances are it wasn't constructed with the same types of materials that we use today. So as a well ages, typically we might expect more potential for well construction to impact that result as well. So transitioning into some of the other common complaints that we get are going to be things that are impacted by the rocks or the soils that water is stored or transported in. So hard water is one of the common complaints that people have, and water hardness results from calcium and magnesium in the different rocks that groundwater is stored in. So limestone, or in the case of Wisconsin, dolomite rocks contain calcium and magnesium. Water flowing through those rocks is going to dissolve small amounts of calcium and magnesium. We consider water to be hard when it's greater than about 200 milligrams per liter of hardness. And then anything less than 150 is considered to be soft water. So while hard water, some of the issues people are going to have are going to be scale depositing on fixtures, maybe in the pipes, on the water heaters. People with hard water tend to go through a lot more detergent or soap because hard water makes it more difficult for that water to form a lather. Those are the typical problems people have that they associate with hard water. When we look at water hardness in Wisconsin, we know that Wisconsin has, in general, very hard water. If you're in eastern Wisconsin, chances are you have very hard water. Southern Wisconsin, the same thing. As we get into northern Wisconsin, the water, the types of rocks or minerals that water is stored in don't contain as much of those elements. So as we progress into northern Wisconsin, we know that the water tends to be lower in hardness, and in some cases even what we would consider to be soft water. And it really follows the geology. Those areas where we have carbonate rocks, eastern Wisconsin, southern Wisconsin, and parts of western Wisconsin, correlate really well with those areas where people with wells are dealing with hard water. If you have hard water, fortunately there's a relatively tried and true technology that helps deal with water hardness, and that's going to be a water softener. So there's a lot of people in Wisconsin that have water softeners on their wells. And these are fairly easy to use technologies that remove calcium and magnesium, but what some people might not realize is that in the process of removing those elements, it has to replace it with something else. And that something else is typically going to be sodium, because we use sodium chloride to regenerate the resin bed of water softeners. So with this method, it's an exchange method. It's removing the unwanted calcium and magnesium, but it's adding back in a little bit of sodium. That sodium, for most people, is not going to be a major concern. But if somebody tells them, or if somebody's doctor tells them that I want you to limit your sodium intake, that additional sodium that's coming from that water softener could be a health consideration that people want to think about. So with water softening, most people will actually bypass their primary drinking water faucet for that reason, that they don't want the additional sodium, but also because a lot of people think that water with calcium and magnesium tastes a little bit better. If you ever have drinking reverse osmosis water, a lot of bottled water might be reverse osmosis water. Some people complain about the taste. They think it tastes flat or it doesn't taste like anything. And that's because we've removed some of those elements like calcium and magnesium. So for that reason, sometimes people will bypass their primary drinking water faucet. And there's really no reason to soften the water that you're using to water the lawn or water your garden. So bypassing the outdoor faucet could also save you a lot of money in terms of softener salt. Transitioning into something else that rock or soil impacts, arsenic is another element of concern in Wisconsin. This is naturally occurring, coming from the soils or other geologic materials. We know that areas on the western side of Lake Winnebago can have some of the highest arsenic concentrations anywhere in the world. And it's due to a specific geologic formation. And that geologic formation has resulted in special casing areas in that part of the state. Those special casing areas are designed to help people avoid having their well in contact with that really arsenic-rich layer. So by adjusting the casing or adjusting the depth of the well, people are able to easily avoid that layer with the high arsenic. The health standard for arsenic, if we look, 0.010 milligrams per liter, or 10 parts per billion, is associated with various types of cancers. So there is incentive for us to reduce exposure to arsenic in our drinking water. Unfortunately, there's a couple different treatment options out there for people if they do have elevated levels of arsenic in their water. This map, it's important to point out that those areas that are blank are just areas where we don't have sufficient data to be able to say with a lot of confidence what typical levels would be. So because arsenic is more recent in terms of our recommendations for testing, we just haven't amassed the same amount of data for some of these constituents. But hopefully through time, we'll be able to fill in this picture and give people a better indication of the likelihood of encountering arsenic where they live. Iron is another common complaint. It might be the most common complaint I hear people talk about in regards to their well water. It's naturally occurring coming from the soils and the rock. Areas where the groundwater is low in oxygen, areas near wetlands or maybe lakes, areas where the soil has a lot of carbon or organic matter tend to have really low oxygen levels. And water that's low in oxygen has a greater ability to dissolve iron that might occur in the soils or the bedrock. So that's why it's probably more common for people that live near lakes or in low-lying areas to be experiencing issues with high iron. While there's no health concerns associated with iron, it does cause some aesthetic issues. That red or that orange staining might look pretty familiar for people. If you have a well at home or you have lake property, that's going to be a common sight. Elevated levels of iron also are going to give water kind of that irony or characteristic well water taste. When I hear people talk about not liking the taste of well water, a lot of times I think they're talking about levels of iron in the water that are giving it kind of a metallic taste. Elevated levels of iron also increase the potential for what we call iron bacteria. That's a bacteria that if you spend a lot of time in the woods, near lakes or wetlands, you might see kind of an oily sheen on the top of water. And I think a lot of people assume that that's gasoline or oil that might have run off a parking lot. But a lot of times that might be naturally occurring iron bacteria. And that same bacteria can occur in people's private wells. It gives water kind of an off-putting taste or an off-putting smell, and it might tend to clog people's plumbing system a little bit. So if people do have high iron, there are treatment options available that would help alleviate some of those concerns, water softeners being one of them. Although if your levels of iron are extremely high, greater than 3 milligrams per liter, a water softener is probably not going to be adequate to reduce all the iron in that well. There might be more appropriate technology available if people have really high concentrations of iron in their water. Manganese is another concern. It's very similar in terms of where and why it occurs to iron. There's an aesthetic level where over that standard or over that level, people are likely to notice kind of black or brown specks in their water. So there's a picture of a toilet tank where there's a fine black sediment in the bottom of that toilet tank, and that's precipitated manganese that's coming out of solution. So black or brown staining might be associated with this element. Too much manganese, levels above 0.300 milligrams per liter, also is a concern for health. Long-term exposure to manganese is associated with various nervous system disorders. Parkinson-like symptoms might result from exposure to elevated manganese in people's well water. So just like iron, there are various types of treatment available that would help alleviate these issues or concerns. pH is another constituent. pH is a measure of water acidity. Most of us are probably familiar or have heard of pH. We know that things that are less than 7 are acidic, things that are greater than 7 are basic. The map shows the variety of pH levels in Wisconsin. Most groundwater pH is going to be in the range of probably 5.5 to 9 on that pH scale. With harder or more basic water occurring in eastern and southern Wisconsin. And as we move north, there's a greater potential for that water to be lower in pH. With areas around Necedah, there's geology there. Because that geology is so void of carbonate minerals, that water there tends to be really low in pH, and as a result is highly corrosive or aggressive. So those areas, people that have metal plumbing are going to have challenges maintaining kind of metal plumbing systems, because that corrosive water may tend to eat away or corrode things like copper plumbing. So when we talk about copper in drinking water, this is also a common concern. Copper is not coming from the groundwater itself. Reasons why elevated levels of copper might occur in drinking water is that plumbing system. So water traveling through those pipes, especially if it's corrosive, has a potential to dissolve unsafe levels of copper. There are health effects associated with that. That's why testing can be useful. But there is also another telltale sign of copper corrosion, and that would be kind of blue-green staining that might occur on people's faucets or their sinks. If you notice blue-green staining, that's probably an indication that copper dissolution is occurring and precipitating on that fixture. Lead is very similar to copper in that the source of that lead is not the plumbing system, or it's not the groundwater, it's going to be the plumbing system. Prior to 1985, lead solder was used to join together copper plumbing, and various brass fixtures will also still contain concentrations or portions of lead. So water coming in contact with those fixtures or that plumbing has the potential to dissolve some of that lead. And notice that the health standard for lead is extremely small. There is no known benefits to lead in the human body. So although levels less than 0.015 are considered acceptable, we want to reduce that exposure as much as possible. Ideally, the health standard for lead should be none. And if we're looking at solutions to lead and copper, if these things are in the plumbing system, fortunately, with private wells, there's relatively easy ways to minimize our exposure to lead and copper. And that's simply to let the water run for a minute or two before using it for drinking or cooking. A lot of times the problem is going to be from water sitting or standing in contact with that plumbing system for a long or extended period of time. So by letting that water run, we're really allowing that water to flush that lead and copper out of those lines. And then next, I want to highlight some of the things that we do on the land surface that can potentially impact the groundwater below. And anything we do, whether it's agricultural activity, lawn care, septic system drain fields, all those things have the potential to pollute or contaminate our water supply. And oftentimes it might not be what we're doing on our property. It might be what somebody else is doing up gradient of our well that's responsible for our water quality. So this is my plug that we all try to be good neighbors. Do unto others as you would have them do unto you. We want to make sure that we're maintaining our yard or our groundwater so that we can protect somebody else downstream. If we look at influences on a well, what I say is kind of a good rule of thumb if you're trying to understand what the major influences are, is pull up a Google Maps and draw a half-mile circle around the well. Chances are pretty good with private wells that what's influencing that well is happening within a half mile or so of the well. If we know the groundwater flow direction, we can narrow that down even further by assuming that water is coming from up gradient of that well. And if we know things about how deep that well is or how deep that well is cased, we often can make inferences about how far away that water might be originating. Shallower wells, that recharge area for that well is going to be much closer. Deeper wells, that water is likely coming from further away. And I think those diagrams on the left do a nice job of highlighting what we consider capture zones for various well constructions. So with regards to land use impacts, nitrate is one of the common things that we look for. Levels less than 2 we consider to be kind of natural or background levels. Greater than 2, there's some human impact that is being had on that water. And then when it's greater than 10, that water is considered unacceptable for drinking, especially for women who are pregnant or trying to become pregnant, or infants less than 6 months of age. Sources of that nitrate include various fertilizers, maybe manure or other biosolids that we're applying to the landscape. Septic system drain fields are also going to release some nitrate, as well as decomposing organic matter. But in general, natural levels of nitrate in Wisconsin's groundwater, we would expect to be less than 2 milligrams per liter. Various health impacts associated with nitrate, which is a reason why it's tested for so often. Noticing that infants and pregnant women are the target population for that standard. Although adults, there's possible correlations to health impacts in adults as well. The other thing about nitrate is that if nitrate is getting through, also an indicator that other possible contaminants might be getting through as well. So if the nitrate is associated with agricultural chemicals, greater likelihood of finding things like pesticides. If that nitrate is coming from septic system drain fields, greater likelihood of finding things like pharmaceuticals or maybe human viruses in that water supply. When we look at nitrate in Wisconsin's groundwater, there's good and bad news. The good news is that about 57% of all private wells that we have data for are less than 2 milligrams per liter in that natural or background level. We do have about 10% of wells, however, that exceed that 10 milligram per liter standard. There's about 2.2% that exceed 20 milligrams per liter. And if we go above 40, there's even some wells that would exceed 4 times that drinking water standard. So while the majority of wells in Wisconsin are actually pretty low with respect to nitrate, we do have work to do. And we do have to put a priority on encouraging people in those areas where we know nitrate exists, put a priority on helping them understand how to test their water. Nitrate is often associated with agricultural landscapes. That's the reason northern Wisconsin, there's a lower chance of finding elevated levels of nitrate in northern Wisconsin than in some of the agricultural areas of the state. Geology also contributes to where we find nitrate, knowing that areas with coarse textured sandy soils are going to be more susceptible to that nitrate from the surface getting into the groundwater than areas where we have heavy clay textured soils. And then areas with karst or shallow soils overlying carbonate rocks, such as we might find in the Door County or Kewaunee County area, we know that that type of geology is also associated with a greater risk of having nitrate in people's well water. So land use is the source of that nitrate, but geology and soils can also contribute to areas being more susceptible. For those that have elevated nitrate, ideally we'd like to eliminate that contamination source, but that could take years or decades to notice measurable improvement. That's why in the short term, people are oftentimes looking at, will drilling a new well get me water that's lower in nitrate? Maybe they choose bottled water. Maybe they choose some sort of water treatment. And water treatment, if you're designing it or using it to remove nitrate, you're really talking about treatment methods called reverse osmosis, distillation, or anion exchange. A lot of people will ask me, does my water softener remove nitrate? And the answer is no. Does that pure pitcher filter that I bought at Target or Walmart, does that remove nitrate? And the answer is no. If we're treating for health-related contaminants, it's really important to know what contaminants of concern is, what level we're trying to treat, and then designing or purchasing a system that we know will be effective for that particular element. And This slide is nice because it points out it makes the point that treatment does come at a cost. These things aren't free, and oftentimes there's maintenance that goes along with it that people have to consider as well. Chloride is another thing that is associated with land use impacts. Natural levels of chloride are going to be typically less than 10 milligrams per liter. Sources are oftentimes very similar to nitrate in that we can get elevated chloride from agricultural activity or fertilizer use, mainly potash that's applied to fields. Some of that is going to be potassium chloride. So the plant needs the potassium, but the chloride is very soluble and can leach into water. Septic system drain fields, especially for those households that have water softeners, are going to be discharging a lot of salt or chloride to that drain field, and that can also be a potential source, as can road salt. So on days like today or during the winter, when we're de-icing roads, we're applying a lot of times sodium chloride. That does a nice job of de-icing or melting the snow off the road, but that's got to go somewhere. And oftentimes it's going to go into the ditch, and in spring, that infiltrating water is going to carry that salt down into the groundwater with it. So some of the highest concentrations that we find for chloride tend to occur near major highways or roadways, or just outside kind of urban centers, because of all the de-icing activity that we have to do in this state. And while chloride doesn't have a health standard associated with it, levels greater than 250 milligrams per liter may give water kind of a salty taste. And really high levels of chloride might actually corrode some metal plumbing. Particularly stainless steel is pretty susceptible to high levels of salt or chloride. The last thing I want to mention in terms of water quality problems is pesticides. This is another common question that we get. Pesticides are oftentimes associated with health effects, and pesticides could include insecticides, herbicides, fungicides, other substances that we use to control for pests. Some of these things are water soluble and can infiltrate and soak down into groundwater. The thing about pesticides is that we don't have health standards for all the chemicals or compounds that are used in Wisconsin. And oftentimes when we do have the research, they're related to the parent compound or the parent product. We know those products can break down into various metabolites, and there's not a lot of research into what health complications might result from the various metabolites that we find in groundwater, let alone research into the combination or the synergistic effects of all those chemicals that might occur in somebody's well water. So while most wells that test for pesticides, most wells don't detect levels above health standards, it's not to say that we wouldn't benefit from reducing the level of pesticides in our groundwater, because we know that roughly 42% of all private wells in Wisconsin contain one or more detectable pesticides. So that's a fairly large number of wells for which we're having some evidence that pesticides are showing up in people's well water. And we know from research that the Department of Ag, Trade, and Consumer Protection does, we know the most frequently detected pesticides in Wisconsin's groundwater are going to be allachlor, metolachlor, atrazine, or breakdown components of those compounds. So we have some data that if people have a private well and they want to test for pesticides, we can oftentimes give recommendations on what chemicals they want to test for. Because pesticides are very expensive to test for, we want to minimize the amount of money that people are spending, so we want to help them target the most likely compounds that they would expect to find. Unfortunately, again, the research shows that we can help people narrow down what tests they might want to consider. So when we talk about wells, we talked about water treatment, and I'd just like to mention that water treatment is often a great option for people to improve their well water quality. It reduces levels of contaminants and other impurities. It improves taste, color, and odor. But there are other things that we have to consider before choosing water treatment. And that's that those devices, once they're purchased, it's great, but unless we're properly maintaining that device, it might lose effectiveness over time. So we have to take into consideration routine maintenance of that device. Treatment also might increase energy use. Things like reverse osmosis or distillation can be quite energy intensive. So that water treatment device might actually increase energy costs that you're paying at your home. And then if we're using treatment to treat for a health-related contaminant, sometimes the only way to know if that device is working properly is to test the treated water as well. And that comes at an additional expense. If you're treating for a health-related contaminant, we really want to understand how effective is that device for improving water quality with respect to those contaminants. Other things to keep in mind is that treatment methods are selective. Know what you're trying to remove, and then purchase the device that you know will work for that concern. And sometimes multiple treatment units might be necessary. So reverse osmosis is great, but it really operates much more effectively or efficiently if that water that's being sent to that device is treated through a water softener. That water softener reduces the amount of scale formation that might plug up that RO membrane. So some of these devices are going to benefit from having multiple treatment devices, which would also add to the cost. So, getting to the end here, I've tried to summarize. If you own a private well, again, you are your own private water utility manager. What are the things to keep in mind with that? And I'd say it comes down to periodically inspect and maintain the area around your well. Make sure that you're looking for the obvious things that might be contributing to water quality problems. Test your water regularly to evaluate common water quality concerns. And if that testing reveals issues or problems, take corrective actions. And a lot of times people find out that there's nothing wrong with their water, that it's actually quite good. And that might come as a surprise to people, especially with how much water quality, well water quality has been in the news. But oftentimes testing alleviates some anxiety that people might have about the quality of their well water. Because a lot of that testing reveals that, again, water quality, well water quality in Wisconsin is quite good. So while testing might indicate problems, a lot of times it might not. And in those cases, no corrective action would be necessary. If you're looking to understand, if I have a private well, what should I be testing for? We would recommend every well be tested once a year for bacteria, or anytime you notice a sudden change in taste, color, or smell. Particularly after or around flooding events, testing for bacteria would be really important to do. If you know the well's been inundated, you really want to stop using it. But if you suspect it's been inundated, you could have a water test done to confirm that suspicion. So anytime there's flooding, it is a good idea. If you're in a flood-prone area, it might be a good idea to have a water test kit on hand to check that well. Nitrate is another constituent that we would recommend every well be tested for annually or once a year. Or anytime there might be somebody in the home who's pregnant or may become pregnant is another important time to test for nitrate. And then third, arsenic is the other thing that we'd recommend every well test for at least once. And if levels of arsenic are elevated, maybe consider testing on a more frequent basis, because all these things with respect to bacteria, nitrate, or arsenic, these are all things that might change over time. So testing more than once can often give us some indication of whether or not the well is stable or whether those constituents are changing. And then based on the other things that we talked about, there might be other contaminants that you consider testing for based on the rock or soil that occur in your area or aesthetic concerns that you might be experiencing with your water. If you're considering testing, the first step, and this is oftentimes a barrier, is people just don't know where to send a water sample. There's information here on how to locate a certified testing lab. The Wisconsin DNR has a website that lists testing labs or opportunities. Find one that's convenient for you. It doesn't really matter where you send a sample. Pick a lab that's convenient for you. And there's labs all over the state of Wisconsin that hopefully make it easy for you to request a sample kit and get that kit back to the lab in a respectable amount of time. I highlighted the Water and Environmental Analysis Lab. That's the lab that I work with at UW-Stevens Point that has a partnership with Extension. And that's where we've customized a lot of the test packages to highlight a lot of the common problems that people might experience with their wells. So if you're considering testing, locate the lab, contact that lab ahead of time, because they're going to have specialized bottles that they want you to use. And they're going to have specialized instructions to help walk you through how to collect that sample. Collecting a sample is easier than a lot of people probably think. Sampling instructions, the vast majority of people are going to be able to follow. And I think it's much more difficult than oftentimes we let on to collect or to screw up a water sample. With a little bit of training, I truly feel that anybody can collect a water sample. Don't let the instructions scare you, because it's probably easier than most people realize. And then lastly, I just want to put up some useful websites. These are websites which I use to put together a lot of this information. And instead of putting web links, I just wrote down what I would use to search for. If I were searching on some sort of search engine, what are the key terms I would put in to access those websites? And that's what that language there is meant to represent. So in the case of, if I'm looking for information on water treatment, we type in approved water treatment devices, Department of Safety, professional services. Following those online search terms should be able to provide you with links to the information that we've talked about here. And with that, I hope that provides an overview of kind of the important responsibility that private well owners have. I hope it provides some perspective on the common water quality complaints or issues people are experiencing, why they occur, where they occur, and then maybe a little bit of information about what people can do if they're experiencing those problems. So I'm going to end it there. My contact info is listed. Feel free to reach out via email or phone. I'm happy to take questions. It's one of the more enjoyable things I get to do is talk with citizens about their well water or groundwater. So don't hesitate to contact me if there's concerns or questions that you have. Thank you. Do we have time for questions, Tom? Yeah? Getting the thumbs up?
As far as transfer of real estate or where there's a well, is there a requirement in the transfer for the wells to be certified?
So that's a great question. And the question is, if there's a property transfer, is that well required to be tested? And the state has no requirement that the well be tested at the time of sale. Mortgage lenders may have requirements for testing. A lot of federal loan programs, FDA or is it USDA loans or Veterans Affairs, if they're sponsoring those loans, they may have testing requirements at that time. If someone chooses to do a well inspection at the time of sale, so just like you can have a home inspection done on your property, which I would encourage and most lenders would require to make sure that what you're paying, that property is worth what you're paying for it. If there's anything found in that home inspection, you can negotiate those costs in that purchase price of the property. Just like you can have a home inspection done, you can also have a well inspection done. That is oftentimes separate from the home inspection, though. It's going to be a different certification process that people need, and usually it's going to be a well driller or a pump installer that has that certification. If someone requires a well inspection for a sale, they are required to test for bacteria, nitrate, and arsenic at that time. So it's not an easy answer to your question. It's not required by the state, but depending on where you get your loan from, there may be some testing requirements associated with it. In general, though, I think it's just like a home inspection. I think everybody that buys a rural property should have a well inspection done. If we looked at some of those prices for a new well, if there's something structurally wrong with the well where it needs to be replaced, I'd say $7,000 is on the low end of what a new well would cost. In some parts of the state, you might be looking at upwards of $20,000 or $30,000, depending on how deep that well has to be drilled. That represents a pretty significant investment in that property. Should something be identified, you can negotiate that cost out before getting saddled with the bill. And testing is an important part of that process. Sure.
When I think about agricultural properties, particularly those that are in continually in crops, and I think about the pesticide issue, and it seems to me like we're talking about a period of maybe the last 70 years or so that we've used what I would regard as chemicals. And so if I say to myself, well, that's only 7 years, if we're putting these things on the soil year after year, there's some soil retention, there's residue in the vegetative matter that gets put back. I say to myself, well, what about in 200 years? Eventually, don't these things work their way into the water table, and will we not have contaminated that depth of soil down to get to the water? Help me through that.
Yeah, so there's a lag time between what happens on the land surface and the water quality below. And I'm just going to back up to one of the first diagrams because I think it'll help explain this a little bit. You know, if we look at the deeper we go into the aquifer, the older that water typically is, the further away or the further away that water originated. What we do on the land surface today might show up in somebody's well in a couple years or decades if they have a shallow well. But when we start talking about really deep municipal wells, it might take longer for that water to reach those layers where those other wells are tapping into the aquifer. So there is this lag time between what happens on the surface and how that water kind of travels through that system. So it might be that the things we're doing today might be in our water, especially those deeper water supplies, for many decades. We do know, though, that if we change land use practices in those areas where we've contaminated aquifers, if we remove the source of that contamination, we can have measurable improvements in our lifetimes. In a lot of the private wells that we use to access groundwater, I would say, it might not happen immediately, but in years or decades, if we remove the contamination source, maybe it's nitrate from nitrogen fertilizers, maybe it's pesticides. If we wait long enough, clean water from the surface will flush that water out. Where is this groundwater all going? It's going to a nearby river, lake, or stream. How long it takes that water to get there depends on basically, where that water soaked down into the landscape. But proof that we can see measurable improvement, I've got colleagues here from the Department of Ag, Trade, and Consumer Protection. So they measure for things like atrazine. So atrazine is one pesticide with a health-related contaminant. And in areas where wells exceed atrazine, sometimes they'll institute what they call atrazine prohibition areas. Areas where they've deemed that the groundwater is just too sensitive or susceptible for that compound to be used. So if we prohibit the use of atrazine, what that agency has seen in some of the wells that they monitor, if you remove the source, if you remove that atrazine, the levels of that compound have gone down in a lot of those wells over time. So while those compounds might be in the groundwater, I do think there is hope that if we remove the source of that contamination, especially with respect to the water that most private well owners are accessing, that we can have or make measurable improvements with some of these issues. Main ones being nitrate and pesticides. I think it's not futile to try and develop strategies to protect the resource.
So do the well drillers have any requirements at the time of drilling to do any testing?
So the question is, do well drillers have requirements to do testing? And there's some minimal testing requirements that they have. They're required to test for bacteria to make sure they're delivering on their responsibility at providing bacteriologically free water. And they're also required to test for nitrate. Although that nitrate testing requirement was added in 2014. If you drilled a well prior to 2014, chances are that it was only tested for bacteria, unless you as the homeowner took it upon yourself to test for other things. And we saw there's literally hundreds of different things that we could test for. Most wells prior to 2014 have only been tested for bacteria.
Oh, it's remember the health problems with like untested water. And the reason I ask is we would behoove the state to, if not pay for yearly testing, to at least give a substantial subsidy to our rural neighbors to test for water to ensure that the health costs that are ultimately borne by everyone.
So
aren't impacted.
So the question is, it's a question I get a lot, which is, does the state have any resources, or shouldn't they have the resources that would help encourage or maybe subsidize the testing? And while that would be great, that money does have to come from somewhere.
Right.
So it would involve the state coming up with a program to help subsidize or cover those costs. We're talking about 800,000 wells in Wisconsin. The average bacteria test is about $20 to $30. A nitrate test is maybe $15 to $20 on average. So we can do the math. That represents millions of dollars. If we're going to require those things, that's millions of dollars just for the testing, let alone the staff to oversee that testing to make sure it's happening, making sure the money's being distributed appropriately and being used wisely. So, it's not a bad idea, but the question is, where does that money come from? And do we have the staff in place to manage that? I pay, so I live in a city, I pay a water utility bill, and you could envision a similar, some sort of similar fee structure or tax anytime a well is drilled that goes to help fund maybe future testing efforts. And maybe it's not every well, but could we do a better job of collecting that data in a way that makes it useful to answer some of these important questions about where is water contaminated? What are the major contributing factors? So, I've thought about that question a lot. What can the state do to promote water testing?
Well, my question really is, wouldn't the testing offset, and maybe there aren't that many costs, and maybe only 10 or 20 people have negative health effects, in which case it's not cost efficient. But if negative health effects, particularly chronic, or longer term, at what point does it make sense for the state to say, we should,
so that's kind of the public's, how we come up with drinking water standards for public water systems. They do that cost benefit analysis. Does reducing this contaminant in the water, if it saves or results in significant health benefits, it's worth investing this much in treatment. That's a similar approach to kind of what you're talking about with private wells. And I don't know, if anybody's done the math to figure out, does that, are there monetary benefits that would be realized by requiring people test their wells?
So nobody's really looked into it as far as you know.
Yeah, and the other thing I'd point out is that, testing is great. It points out that there's a problem. But if those people don't have the monetary funds or the ability to pay for treatment or drill a new well, that's the other concern. Is testing is great, but without the means to actually do anything about it, that's the other piece of the equation that we think about is how do we maybe help compensate people if they have water quality issues, to make sure that they can do something about it. Sure, question.
Are you aware if the county health rankings look at water quality, and if there would be health issues that you could see in the 72 counties, if there are counties that have more water quality issues?
So the question is about, do county health rankings look at water quality?
Yes.
And that is something that they try to look at. We're really good at doing that, I think, at having the data to make those those types of research questions for public water systems. It's much more challenging to have the data on private water supplies to do really good epidemiology type studies on health effects. One is that the well water or the data on groundwater can sometimes be sporadic. The other thing is that the health data, some of the health impacts that we're looking at might not be tracked very well. And then we also have to assume that just because these things are in people's well water, it doesn't necessarily mean they're drinking that water. They might be using bottled water. They might be getting a lot of their water from work or school. So just because these things are in water doesn't necessarily result in direct exposure. So all those things make, I think, answering that type of question or using the data to answer that type of question challenging, to where I know that's something they want to look at. The Environmental Public Health Tracking Program has had discussions about, can we do that? But up to this point, I think they've found it challenging to be able to say with a lot of evidence that yes, we know that this water is causing this health impact. Sure. Tom had his hand up.
Let him go first. No, go ahead, Tom. You can go. All right, you'll probably ask the same question I was going to ask. I know. The governor just tweeted out a map yesterday or today about lead poisoning, which can come from tanks or a lot of other things besides water. But having gone to school at UW-Platteville in the old mining district, how likely or how often do people detect high lead in water, not from pipes, but from the groundwater because of the presence of lead mineral?
I'm not saying it doesn't happen, but in the 15 years I've been with Extension, anytime I get a really elevated lead, I'll send another water test to those folks and ask them to retest after flushing the line for 2 minutes. And I've always seen that if somebody does that, the level comes back low to non-existent. So to me, it could be a possibility. Especially, I haven't done a ton of testing in the old lead districts of Wisconsin. I have done some. But in general, if somebody's got an elevated lead, I'd say 95 to 99% of the time, the source of that lead is the plumbing system.
And that's a pretty straightforward test, running it before and after flushing for 2 minutes.
So we always encourage people to take a first draw. If they're testing for lead, we tell them to take a first draw sample. We want that water first thing in the morning, after that water sat in those pipes overnight, because that's going to give us the worst case scenario. What's the highest concentration of lead that I'm likely to have in my well water?
And is hot water better than cold water if you want to maximize lead?
If you want to maximize lead, yes. But that's why we would generally say you never want to use hot water for drinking, or even filling up. If you want to cheat and you're making pasta, you might be tempted to fill it up with hot water to save some time in terms of heating it. Hot water would dissolve higher concentrations of lead, so we never want to use hot water for drinking or cooking. Sure.
Is there any place to look for historical data of the testing of various areas, or do you just have to kind of hunt and peck for something like that?
So that's where this well water viewer, I didn't describe it in a lot of detail, but a lot of the maps I showed are from the Wisconsin well water viewer. This is an extension tool that combines our data set, data from the DNR, data from DADCAP. It's not all the private well water data that might be out there, but it's data sets that are readily available to us that we've combined and aggregated and put on this mapping tool. So this is accessible online. Anybody can go here and see or generate maps like this. There's a search tool that if you draw a circle, it'll generate a table highlighting the information in it. The downside is it doesn't give you access to the granular data. It aggregates it together. And that data spans probably 30 or 35 years. So it helps us highlight those parts of the state which we know probably have issues with things like bacteria or nitrate. It doesn't provide people with the opportunity to look and see how has groundwater quality changed over time. We're looking at doing a better job of doing that with some of the recent testing requirements for nitrate and arsenic at the time a well is drilled. That's going to generate a lot of data that will help us answer that question of how is groundwater changing with respect to nitrate, with respect to arsenic. The other data set, the useful data set that we have, there's a classification of community water systems called transient non-community. Those would be bars, restaurants, churches that are required to test for nitrate annually. Some of that data goes back maybe 15, 20 years. That does provide us with an ability to understand, how has groundwater changed with respect to nitrate. So there are data sets available. A lot of times they might not be as extensive as we'd like. I mentioned this is 30 years worth of data. If we wanted to increment it and look at maybe the last 5 or the last 10, what we'd see is we lose a lot of detail. We wouldn't generally have enough information if we start incrementing or separating it out by decades. We wouldn't have as complete a picture of groundwater or well water quality in Wisconsin. So, as limited as our data is, Wisconsin is far ahead of a lot of other states in terms of access and accessibility of groundwater data.
So are you saying that you have the ability to look at more data rather than the aggregate comparatively?
Yes.
Okay, so if I were to contact you about a specific area, like you mentioned, anything within a half mile of something, so that would give you would have more ability to access that data specific for that.
I would, if you have the right tools or the right skill set. Some of that data you can download from the Department of Natural Resources through the Groundwater Retrieval Network. You have to be good at working with data, working with spatial data sets, but there are avenues for people to do that. The simplest thing, though, is to go online, search for the Wisconsin Well Water Viewer, and if you're interested in a specific part of the state, you can draw a circle on the map, and it'll generate a table telling you what we know. Maybe we don't know anything. Maybe it's one of those blank areas where we don't have a lot of data. But if it's in Columbia County or Portage County, chances are there might be hundreds of samples in a couple square mile area that would help understand what are the typical problems that people are experiencing.
Related question. I get my water tested in Door County. There's like 5 different companies that you can basically choose from when you go to the health department. Do those companies share the data with one another, or if I stay with UW Stevens Point, will you give me a cumulative review over the years of how my water tested out? And then related to that, do the nitrate levels change from year to year?
So a lot of questions.
Yes, they do.
Yeah, so the first question, if I'm remembering correctly, is do all labs share their data? Do private labs share their data? And unless it's for a required test, maybe a well driller or a well inspection, chances are they're not sharing that data. In fact, they won't. They likely won't. They will if it's done for a required test at a time a well is drilled, they're required to report that information to DNR. But the average homeowner, if you're testing annually and taking a sample in, chances are that's not going to see the light of day. So that was your first question. Second question?
Is if you stay with one lab, are you able to get a report that shows a cumulative report from year to year to year and how things have changed?
So if you stay with the same lab, are you able to get a cumulative report? And it would depend on the laboratory, how well they maintain that data in a database, how easily accessible that information is. So Stephen's point, we have a database that we've maintained for 30 years. If you tested 20 years ago, I could pull up your previous test results and send those to you, or all the test results that you've had. Other labs might be able to do that, but I can't comment on all of them. A lot of times it's a staffing issue. It costs money to maintain that data set and continue to update it. And to the degree to which everybody does that, I don't know.
You had stated that bars and restaurants have to do that yearly. Can you see that data set so that I can access that? So
any community water system, that data gets reported to the Wisconsin Department of Natural Resources, and it's available with a little bit of training. Anybody could download it. It's not intuitive though, so you kind of have to search your way through it. But you could, if you had a specific restaurant that had a private well, or there's a community water system for your area, you can go to the groundwater retrieval network, and you would be able to see the results of all that testing that's been done. And municipal water systems are required to provide consumer confidence reports.
I was just looking at an area. You could look at a whole area.
Yeah. It would be, again, it's, you could download the data to get to the point where you could visualize it. We're trying to do better at providing that in an easily accessible way. It's publicly available. The degree to which the average user can use that is questionable, but hopefully it'll get better. Sure, another question here.
Yeah, everyone's talking about lead, which old plumbers often consider to be kind of unnecessary fear-mongering, but everyone is shifting to PVC.
Mm-hmm.
Is there any testing? Years ago I read about some water problems related with PVC in California testing. Is any water being tested for results of
So we talked about how plumbing can impact water quality, and while traditionally we've used copper, a lot of homes are switching to PVC, or PEX is another name that people would use. That's the flexible plastic tubing, which is really easy to work with. If you're trying to bend it around or through walls, you don't have to do any more soldering. So it's very convenient. And anything water comes in contact with, there might be some potential to dissolve small amounts of those substances. But I would say the risks are low, for the same reasons why lead, if we let the water flush for an extended period of time, that water doesn't have sufficient contact time to develop unsafe levels. And I think the same is true for PEX. If there were things in that material that were a concern for drinking water, simply letting the water run before using it for drinking or cooking, I feel would be sufficient at alleviating any issues that might result from that.
Regarding her question, why doesn't the state require the private labs to send the data to the state that they get for the testing of individuals?
I don't know. I suspect it's probably it's an additional expense.
Postage
Yeah. It's a privacy issue, as Rick stated. If it's required at at various times at well construction, that's one thing. But if somebody is, just curious about their water, maybe they're evaluating a water treatment device. Maybe they're, testing because somebody in the household's pregnant. Those are, then we start bordering on health and privacy concerns. And, then it becomes a little bit trickier to say that that information should be in a database. Because what other information is being given away if somebody's voluntarily testing for unknown reasons versus required testing? There's also a chain of custody that comes into play. A lot of the testing we do is voluntary testing, people bringing in a water sample on their own. I can't vouch for the accuracy of that water test. They put down their mailing address, and we ask them to put down a well address. If they leave the well address blank, do I assume that their mailing address is where that sample came from? It might be their property or their cottage up north, which doesn't have an address. Therefore, there's much greater opportunities to create errors if we're requiring information that's voluntarily submitted without that chain of custody. There's a lot of challenges in terms of managing that data. That, as Rick mentioned, some of it has to do with privacy. Others has to do with kind of the accuracy. How accurate would that data be? And while I hope that most people are being upfront and honest with the samples they submit, there could be opportunities with voluntarily submitted data to either make it look like the data is better than it is or worse than it is. So I think that's the other challenge, is if we can't vouch, if we don't have that chain of custody, how much weight do we put on that data set? How much confidence do we have that it's representative of that well or that property? So, again, I've wrestled with a lot of those same questions, and it's sometimes challenging to understand what the best course of action is.
If you have multiple wells in a particular area, is it reasonable to make any kind of assumption that a sampling of some of the wells gives you a good test about all the wells within a particular area? So
the question is regarding, if you have multiple wells in an area, does testing, does information about all the wells, can you make some assumptions about a well that hasn't been tested, or what can we learn from testing wells? And while I think it's useful to aggregate data, it helps us understand that when we test wells in eastern Wisconsin, we have pretty high confidence that it's going to be hard water. We know they're all coming from the same aquifer. We'd have less confidence that all the results in, let's say, a township are going to give us some predictive ability for something like nitrate, which is related to land use impacts. Aggregated data, in my opinion, is not a replacement for individual well water testing, because wells located in very close proximity to each other might be widely different because of the flow path of water to that well, or, as we saw in some of the diagrams, the depth to which that well is drilled will result in sometimes completely different water quality. So while aggregating data is good, it helps us look for trends or patterns, spatial patterns in particular. It is not a replacement for an individual well test. So that's my plug. That's really why it's important. Anytime you're purchasing a property, or if you own a property with a private well, you can't necessarily rely on this information to tell you what is the water quality in your well.
Thank you very much.